All right, so to start with, I'm just going to talk a little bit about what index laws are and show you some examples. So we have index notation, right? So what we'll do, Alfredo, if you've got your notes book open to 12B, and we're going to follow along with the notes book. That's what we'll start with. All right, so everyone's got the notes book open to 12B. Okay, so to begin with, we won't get straight into the first question. I just want to talk about index laws and where we sort of derive them from. So we've got the definition of index laws there, right? So if I have 2 to the power of 3, what that means is 2 times 2 times 2, right? We're multiplying it 3 times, okay? And so similarly, if I had 2 to the power of 3 multiplied by 2 to the power of 4, all right, what this is going to be, it's going to be 2 times itself 3 times, and then we're going to multiply that by 2 times itself 4 times. And then if we're just using index notation, we can go, oh, we've got 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7, all right? And so then you can see, oh, all we're doing is adding the powers together. We have a to the m times a to the n, a to the m plus n. So that's the first index law there, right? Okay, so in 12C, there's a summary of the index laws. That's the first one. You start learning them like year 7, year 8. So we're going to be applying all of these index laws to the problems in 12A, 12B and 12C. All right, so with 12B, that introduces you to the index notation, and we've got written down that we're going to discuss some of the questions together. So we might open our textbooks to 12B. All right, so 12B, what page is that, Francesco?
327.
327, so textbooks on 327. And this is a good way for us to make sure we're getting the knowledge we need without having to waste time writing it all down and so forth. 12B, 327. Okay, so question 1, like I might do the first one for you and then you can have a go at B and C. So it says list the first 6 powers of 2. So that means 2 to the power of 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6. Say first 6 powers, yeah. So 2 to the 1, that just means 2 by itself, right? 2 to the 2 means 2 times 2, 2 times 2 times 2. So all we're doing is multiplying that number by 2, 16, 32, 64. All right, so they're all the powers of 2. Now you should probably know the first 5 powers of 2, 3 and 5. So 2, 3 and 5, the first 5 powers are good to know. So that's question 1. And then we've got discuss question 3. So one of the rules I've pasted in the notes there. Okay, so we've got the first box is explaining it, the second box. A negative base raised to an odd power will be negative, and a negative base raised to an even power is going to be positive. Maybe I can explain why that's the case. So if we have minus 1 to the power of 2, all right, that's going to be minus 1 times minus 1. The negatives cancel one another, right? That's going to become positive. If we have minus 1 to the power of 3, okay, the negatives here are going to cancel each other, so that part's positive, and then we're making it negative because we're multiplying it by another negative, okay? So the rule is if it's an even power, then the result will be positive. If it's an odd power, the result will be negative. So let's have a look at question 3A there. Can everyone see question 3A? And we've got minus 1 to the power of 5. So we can see it's minus 1 to the power of an odd number. So that means the result is going to be negative. All right, when it's to an odd power, it's going to be negative. All right, so we might go through. So Joel Lee, we've got B there, minus 1 to the power of 6. Is that going to be negative or positive? Very good. Mace, B, C?
Yeah, positive.
Positive, good. And Will, D?
Negative.
Negative, okay, odd number. That's all you're doing there. Excellent. So that will do for 12B. Let's move on to 12C and we'll have a go at these example questions together. So I'll start writing them up and you're going to record the solutions to these example questions in your notes book. So we have 2 to the power of 3 times 2 to the power of 5. All we're doing here is applying the first index law. So we add the powers together, right? The base, they have the same base, so we can add those powers together. 3 plus 5, it's 2 to the power of 8. Now when I'm doing these kind of questions, I will show that intermediary step. Completely unnecessary. When you're doing it in a test situation or in your workbook, you just go straight to the 2 to the 8. Okay, on to B, we have 3 to the power of 7 divided by 3 to the power of 2. Alright, so we have the same base. Now we're going to use the second index law. Alright, and the second index law tells us it becomes the top power, take away the bottom power. So that's going to be 7 take 2, 3 to the power of 5. Okay, stop me at any stage if you have a question. Alright, we have 3a squared. So now I'm looking at the fourth index rule. Alright, if we have ab to the power of n, this power needs to apply to both terms. So this is going to be 3 squared a squared. And to write it in simplest form, that's 9 lots of a squared. Okay, so notice how the power applies to both. Alright, for D, I'm going to come up here. Okay, so the 3 needs to apply to everything inside the bracket here. So it's going to be 2 to the power of 3. It's going to be b to the 4, and that is to the power of 3. We have b to the 4 to the power of 3. We're using the third index law. We multiply those powers. Okay, if that's to the power of 3, 4 times 3, on top of a to the 3. We'll simplify this. 8, b to the 12, a cubed. All right, everything to the power of 4. So this negative belongs to the 3, right? So we have minus 3 to the power of 4. A to the power of 2 times 4, and b to the power of 4. So this is minus 3 times minus 3 times minus 3 times minus 3. It's a negative to an even power, which means the result is going to be positive, and 3 to the power of 4 is 81. 81, a to the power of 8, b to the power of 4. Very good. So there's the first sort of powers of 2, 3, and 5. That's going to help us answer question 2. Question 2a, express as a single power of 2, 3, or 5. So if we have 4, we're going to express that as a power of 2, right? And that is 2 to the power of 2. All right. For B, we have 1 on top of 9. Alright, so 9 is a power of 3. So that's going to be 1 on top of 3 squared. Okay, and if we're writing it as a single power of 3, one of the index laws we're going to be using, I'll point out which one, the very last one, right down the bottom. We can express this as 3 to the power of minus 2. Alright, so this 3 is at the bottom, it has a power of positive 2. We can take it to the top of the fraction, provided we make the power negative. Okay, that's what that means. This one will pop up again a bit more, so don't be alarmed if you're a bit worried about that. On to C, we have 5 times 25 to the power of 8. Very good. And we want to write this as a single power of 5. Well, what we have here is we have 5 to the power of 1, and we're multiplying that by 5 to the power of 2 to the power of a, right? 25 we can express as 5 squared. Yeah? And then we have 2a, so when we have 5 to the power of 2 to the power of a, that's going to become 5 to the power of 2a. We multiply those powers. And then the last step is that these have the same base. We're multiplying them, which means we're using the first index law where we add the powers. It's going to be 5 to the power of 1 plus 2a. Alright, we've expressed this as a single power of 5. Okay, on to D. Alright? No, all good? Yeah. So we have 4 to the n plus 1 on top of 2 to the power of x. So our first step is going to be to express this as a single power of 2. 4 is 2 to the power of 2. And we have a power of 2 at the bottom. Then this power here multiplies the 2, right? So that's going to be 2 to the power of 2n plus 2. That 2 multiplies both of those on top of 2 to the x. They have the same base, so it's the top power take away the bottom power. So we've simplified all of this to express it as a single power of 2. All right, on to question 3. Write in non-fractional form. Now, whenever we have something expressed like this, there's lots of ways we can write things mathematically, right? One of them would be like this. We could write it as 3 times 1 on a to the power of x. We could do that. That's legit, okay? If you're going to expand this fraction, that number goes to the top, right? And why that's useful, why I put this intermediary step in, is to show you if we have 1 on top of a to the x, we can express that as a to the minus x, right? We can take it to the top of the fraction, provided we make its power negative. The 3 just hangs out. It's 3 times. This is the same thing, different ways of expressing it. The question asks us, write it without a fraction. That's what we've done. We've expressed it all at the top. So that was 3a. Let's go for 3b. We have x plus 3 on top of x squared. Okay, I'm going to put that intermediary step in again. That's x plus 3 times 1 on x squared. And 1 on x squared, the way we would simplify that is take the power to the top, but make it negative. All right, again, I'll split them. 1 on top of b to the minus n. I'm going to take the b to the top and make the power negative. All right, so the power was negative m. If I move it to the top, if I change its position with regards to the fraction, I need to put a negative in front of the power, and the 2 negatives will make it positive. ab to the power of m. All right, that's 3. And our last question here. It's question 4. Write without negative powers, without negative indices. So we have a to the minus 4. I've said we can take it to the bottom of the fraction and make the power negative. All right, so we're changing it from negative 4 to negative 4. Which becomes positive 4. So that's 4a. 4b, okay, this is good. I've set this up like this on purpose. This, now beware, this and this are not the same. Okay, very clearly. This tells you that power applies to both terms because they're both inside the bracket. Here, the power only belongs to the A. So that means the 3 stays at the top, and this becomes 1 on A squared. It goes to the bottom. All right? And we've successfully expressed it without a negative power. So that's the answer to B. I only put that up there to stress that power only belongs to the term it's written above, unless there's brackets around it. And then C, A to the minus 4 on top of B to the minus 3. All we're doing here is if it's a negative power and you want to make it positive, you swap its position in the fraction. So this is going to become B to the 3 on A to the 4. All right? I've moved the A to the bottom and made it negative, negative 4. I've moved the B to the top, negative, negative 3, B to the 3. Very good. So, we've discussed our 12b, all right? If you want, you can have I've sort of wrote those first 5 powers up anyway. So I think we're done with 12b and we're ready to have a go at 12c. 12c is probably the most important exercise in this textbook. I really mean that index laws are really, really, really important. So, you see the checklist on the previous page, right at the start of the thing. If we look at 12c, we've got questions 1 through 12 written down. That's what we're going to work through today.